This is the screencast for section 10.3, example 3, polar curve. So now we're going to graph with technology or our calculators. We're going to find an appropriate graphing window, which I think is the trickiest part, and produce a graph of the polar curve. So a trick that I think is good for finding windows for polar curves is thinking about what the maximum R value is. So here in example 3, part A, R equals the sine of 6 theta. Now, this vertically, nothing is happening to the sine curve here. Sine is just being horizontally shrunk by 1/6, so you're still going to get out a range of -1 to 1. So your maximum R value is either -1 or 1. It just changes directions, but basically it's the maximum R is going to be 1. Which means then my trick would be to set my Y min and Y max to -1 and 1. And then of course I'm going to keep that 3:2 ratio of X to Y that we talked about in the last screencast. So then that makes the, let's see, down here, the window, X min -1.5, X max 1.5, Y min -1, Y max 1. Part B. Thinking about what the largest R value could be, or the smallest negative-wise. Cosine fluctuates between -1 and 1. So +1 is going to make 1 minus 2, so that's -1. But -1 is going to be 1 minus 2 times -1, so really plus 2, that's 3. So the largest R value is going to be 3. So then I set my Y min and Y max to -3 and 3 respectively. Then keeping the 3:2 ratio, -4.5 to 4.5 for my X min and max. Part C, R equals 4 sine theta. So sine fluctuates between -1 and 1, the range does, and then you're stretching it by 4, so really -4 to 4. Again, in polar coordinates, that just means opposite directions. Your largest R value is going to be 4. So that means I set my Y min and Y max to -4 and 4, kept the 3:2 ratio, so -6 and 6 for the X min, X max. The now try problem, number 13, says find an appropriate window and use a graphing calculator to produce the polar curve. Then sketch the complete curve and identify the type of curve by name. So this curve by name thing, this is something you were introduced to a little bit in pre-calc. You do not need to have them memorized, but in case the directions ask you for them, there is a gallery at the end of your notes that we'll show you in a minute here. So R equals 2 cosine of 3 theta. Well, the cosine of 3 theta is going to fluctuate between -1 and 1, so R's min or max is, or excuse me, R's max is going to be +2, really -2 or +2, but again, that's just a directional thing. So the largest R is 2, which means I am going to put R equals in polar mode on my calculator, 2 cosine 3 theta. I'm going to do a theta equals 0 to pi. Now, technically, the period of this cosine curve is going to be 2 pi over 3. So I could have set this to 2/3 pi for my theta max. I just didn't. Now, the largest R value is going to be 2. So that's my Y min and Y max, -2 and 2. And then to keep the 3:2 ratio, my X min and X max are -3 to 3. So I get this lovely graph, which if we look to the end of our notes here, a small polar gallery, this looks like, right, actually this one, a type of rose curve. As I graphed it, it moved in this direction, so I could make little notations like that, and then I will call that a, for my sketch, sorry, and then I'll call that a rose curve. Isn't that pretty? Hey.